Hello and welcome back. So we now find ourselves at presentation number 5 out of a series that we've done on turning points in calculus. And this is just to wrap up really. This is another example and it'll finish off the process that we've been through, and I'm not going to dwell on it too much. I'm going to go through it relatively quickly. If you get stuck, obviously you can go back to the beginning and watch it again, but really if you need to go into more depth, you really need to look at the previous videos I did from number 1 onwards, where I go through basically the principles of what we're going to cover in here. So in this example, we've got the volume of a cone is given by the formula V equals 1/3 pi r squared times h, where h is the height of the cone and r is the radius. If h is made equal to 6 minus r, calculate the value of r for which the volume is a maximum. With these examples, quite often the hardest bit of it really, once you've done a few and you get an understanding of it, the hardest bit really is understanding what approach to take. And usually the first place to start is start thinking about your formulas. So we've got a formula there, V equals 1/3 times pi r 2h. Okay, so if it and h is represented by 6 minus r. So if let's have another look at that. So we've got V equals, so we've got 1/3 pi r squared, and then for h we've got 6 minus r, so I'm going to put that in there, substitute in, put it in brackets, thus we have that. If I multiply that out, quite simple, multiply that into that, it will get V equals, so we'll have 1/3 into 6 will make that 2 pi r squared minus, and then we'll have, I'll put it in this style, 1/3, I could have put 3 underneath everything, but 1/3 of pi r, we've got an r there and an r there, so it's going to be r to the 3. Okay, and we're now, so very quickly differentiate, so it's dv in relation to the radius, fairly straightforward. So this has become 4 pi r, take the 2 to the front, multiply it in, take 1 from the power. This would become minus, so that 3 will come to the front, so it'll cancel, so we'll just have pi r to the 2. Okay, so when dy over dy, dv over dr equals 0, therefore 4 pi r must equal pi r squared. So for all this to give us an answer of equal to 0, so when a gradient is 0 for that turning point, then that must equal that, as it wouldn't equal 0. Okay, let's have a look. So we rearrange it. Let's just move the screen up a little bit, gain some space. Okay, so if I rearrange that, it's quite simple. Take my r over here, my 4 and my pi over there, and I will get 4 equals r, or r equals 4. So the pi's have cancelled when I've divided through by pi, it's cancelled, and one of the divided through by r, and it's cancelled with one of the r's on the top, so I'm left with 4 equals r, so radius equals 4. I'll just change that the other way around. Okay, so the only thing to do now is to test to see if it's a maximum or a minima. Let's have a look. So differentiate again, we'll go straight to the shortcut on this. See my previous presentations on other methods. So differentiate again, so d2v divided by dr squared gives me, so it's this formula up here I'm doing, so I will get 4 pi minus 2 pi r. Okay, right, is that if I put my 4 into this radius, will I get a negative answer or a positive answer? I don't really need to do the maths at all. I just need to know if it's a negative or a positive number. So obviously, if I put 4 in there, I'm going to have my 4 pi might be 4 pi there. This is 2 times bigger, so obviously it's going to give me a negative answer. So I'm going to get, ooh, pen doesn't want to work, negative. Certainly slow today. And negative, which is equal, well, not equal, but implies that it's a maxima. Maxima. Okay, sorry, yeah, my maxima. So it's a maximum volume when the radius is 4. As simple as that. So that's a straightforward example just to finish off with. So hopefully you've enjoyed this series of 5 videos, and this was certainly the quickest by a long way. And thank you for listening, and I hope that all of much use to you in your learning. Thank you.